So hi friends, in this lecture let's discuss a problem on minor losses. So we've been discussing on the losses in pipes. So as you know that the losses are major and minor losses. So minor losses we have discussed in the earlier chapter. What are the minor losses that occurs in a flow of fluid in a pipe? So for one minor losses, so that is due to sudden expansion, I have given a sample problem. Okay, so the rest follows the same. Let's go into the problem. The rate of flow of water through a horizontal pipe. So the pipe is horizontal. So the flow rate is given, which is 0.25 meter cube per second. So per second it's 0.25 meter cube. So if you into 1000, it will probably work out to be around 250, 25 or 250, right? So the diameter of pipe, which is 200 mm, is suddenly enlarged to 400 mm. The pressure intensity in smaller pipe is 11.772 Newton per centimeter square. So we need to determine the loss of head due to sudden enlargement, pressure intensity in larger pipe, and power loss due to enlargement. So here we have a sudden expansion. So pipe suddenly enlarges from 200 mm to 400 mm. Due to this sudden enlargement, what will be the loss of head and what will be the power loss due to this enlargement? So and also we're going to find the pressure intensity in larger pipe. So from smaller pipe to larger pipe, there will be some difference in pressure, right? So we're going to find out head loss due to sudden enlargement, density and pressure, pressure intensity and power loss due to sudden enlargement. So it's given that discharge 0.25 meter cube per second. So diameter of smaller pipe, as we said, we're going to convert into meters. So we know area will be pi by 4d square. So this will be the area of the pipe 1. So diameter of the larger pipe, we're going to take it as 2. So the area will be 0.12566 meter square. So pressure in smaller pipe is given as 11.772 Newton per centimeter square. So we need to convert into meter square. So into 10 power 4. Okay. So now the velocity will be, as we know that from discharge will be equal to area into velocity. So velocity will be equal to discharge by area. So we know the area of pipe 1 and pipe 2. So we can, from them we can able to find the velocity at pipe 1 and velocity at pipe 2. So if you substitute and simplify, the velocity in pipe 1 will be 7.96 meter per second and velocity at pipe 2 will be 1.99 meter per second. So there is some reduction in velocity which is due to sudden expansion of a pipe. So if the pipe is the diameter of the pipe increased and the discharge remains same, probably the velocity has to reduce. Okay, this is a simple concept. So first we're going to find what is the loss of head due to sudden enlargement. So we know the formula which we have already discussed in the previous chapter. So Hg, which is head loss due to sudden expansion, will be equal to V1 minus V2 to the whole square by 2g. So V1, V2 is known. So we substitute and we can able to find the head loss will be 1.816 meter, which is the head loss in terms of meters. The second one, loss of head due to sudden enlargement, we have already found. So which is 1.816 meter per second. Let the intensity of pressure in a larger pipe be P2. So we know the P1, so P2. So based upon Bernoulli's equation, so P1 by rho g plus V1 square by 2g plus Z1 will be equal to P2 by rho g, V2 square by 2g plus Z2 plus head loss due to sudden expansion. So it's for a real fluid, so we consider the head loss. So it's a horizontal, it's already said in the statement it's a horizontal pipe, so Z1 will be equal to Z2. So this becomes P1 by rho g plus V1 square by 2g equal to P2 by rho g plus V2 square by 2g plus head loss. So we know all the values except P2, so we can substitute the values. So P2 by rho g will be equal to this equation. Simplifying, you can take this to the other side. So then the P2 will be equal to, if you simplify this thing, P2 will be equal to 12.96 Newton per centimeter square. Right. So here the pressure has been increased and velocity has been decreased. In a larger pipe, the pressure is increased, velocity is decreased. So what is the power loss due to the sudden expansion? So we know that power loss in the water, in the flowing fluid, will be weight density, discharge and head losses. So weight density 1000 into 9.81 means for water, so 1000 will be the density. Q already given 0.25 and head loss due to expansion is 1.816. So if we substitute and find out, so it will be 4.453 kilowatt will be the loss of power. So thank you guys who would have got few glimpse about this loss due to sudden expansion. Thank you.